Based on the polluter pays principle, each country is supposed to finance the elimination of its own debris. Since 2013, space engineers have been creating a new profession: space garbage guy. The idea is to come up with robotic systems that can deal with large pieces of garbage by sending them into a junk incinerator, the Earth's atmosphere. But it's a difficult task, since orbital debris moves like an asteroid, spinning around as it orbits because of gravity. Around the world, laboratories have been coming up with robot satellites that could capture debris and deorbit it. That's what they're working on at the Remove Debris project at the Surrey Space Centre in England.
In a real mission, you'll be dealing with uncooperative debris that may be spinning.
Space engineers use technical terms, but their projects seem more like children's games.
One of the technologies we have on our mission is the Harpoon.
It seems unlikely, but the team is developing a harpoon capable of attaching onto a piece of debris in order to drag it into the atmosphere.
In our mission, the Remove Debris mission, the thing we're actually testing is the impact mechanism of the harpoon on an actual target plate.
The team is still at the experimental stage, where it is testing a miniature harpoon on a stationary target. First attempt.
3, 2, 1, fire!
Failed. The harpoon did not leave its sheath because of an electromagnetic problem. Second attempt.
Hopefully the harpoon should be able to impact exactly where you want it to hit.
3, 2, 1, fire!
The trial and error method is a long process, but the team is improving its system. The first full-scale test in space in 2019 was a success.
Hopefully, when that goes into space, because of the lack of gravity, the alignment should be much better than the tests we can perform on Earth.
The trial and error method is a long process, but step by step, the team is improving its system. The first full-scale tests in space will take place in 2020. The harpoon is not the only tool envisaged by space engineers. The South Africa Space Agency, created as recently as 2010, has come up with its own cleaning solutions that it hopes to market later. One of their projects involves building a small satellite capable of unfolding its tentacles to capture debris, hence its name, Medusa.
Medusa will enclose the debris and drag mover to where it needs to be, either to grave orbit or you decrease your altitude and eventually toss this debris back into atmosphere and let it burn up as the re-entry.
Another advantage of the Medusa satellites is that they can be launched in squadrons, as tests from the International Space Station have shown.
Medusa it's very light, it's about 175 grams. It is designed to be put onto CubeSats, which is satellite this size.
A CubeSat is a small, multi-use satellite in the shape of a 4-inch cube. Developed by a Californian university, dozens of them can be launched at a time, which keeps costs down. It's a godsend for researchers who have no other way of running experiments in space. Coupled with CubeSats that have already proven themselves, Medusa should be able to eliminate debris over a long period.
At the moment, there's a lot of proposals like Harpoons. A lot of them are one use, so you fire it one time, you miss, you miss. The uniqueness of Medusa is that it allows multiple attempts, so the idea is to use it many times as you can to remove small targets.
But the drawback with Medusa is that it only targets small space junk. For large, non-functioning satellites, other tools are necessary, which opens up the problem of financing these operations.
Unfortunately, none of these solutions is ready for use. Nobody is ready to pay the high price necessary to get rid of large orbital debris.
The bigger it is, the more it causes problems because any damage creates more junk. The largest non-operational piece is Envisat, an observation satellite the size of a bus that was launched in 2002 by the European Space Agency. At the time, the agency was trying to get the biggest return from their investment, but today, Rödiger distances himself from his predecessor's actions.
They just want to maximize the revenue. They use the last drop of fuel for their operations rather than using the fuel for deorbiting, and this is the problem.
When it was built, it was the largest observation satellite ever constructed. After 5 years of activity and having circled the Earth around 30,000 times, it should have been deorbited before the end of its mission. However, 10 years after being launched, the European Space Agency lost all control of Envisat on April the 8th, 2012. Today, it is a ticking time bomb as it crosses paths with many other working satellites. The situation is so critical that the European Space Agency is funding an ambitious program to try and remove Envisat from its orbit.
We believe that throwing a net could be an option, because throwing a net means you will later have a connection by a tether. And that means the captured Envisat inside the net can be pulled.
To test this space net, engineers use an aircraft to recreate space's zero-gravity conditions. At the top of its parabolic flight, in the form of a bell, it releases passengers and objects from Earth's gravity for several seconds. Enough time to test a miniature version of the net they will use to catch an 8-ton satellite. Tests have proved that adding weight to the corners of the net allows it to enclose the body of a satellite without snagging on its fragile solar panel. Now, all they have to do is build a tractor satellite that can retrieve Envisat and return it to port.
Envisat is 8 tons, certainly more heavy than the removal vehicle. When you have to remove something which is more heavy than yourself, it's better to pull than to push, because that gives a more stable scenario.
Though it is essential for space safety, even this project is still in the theoretical stages, for one simple reason.
We have investigated the problem to look for a solution, but it would cost €500 million.
For technical and economic reasons, no robot garbage collector is ready for work at this time.
For this to become workable, the cleanup operation would need to be free, like if it was a passenger on another mission, and what seems to be quite promising is what we call space tugs.
The space tug would be multifunctional, a kind of space-based Swiss Army knife.
On Monday, it would refill a satellite. On Tuesday, it would repair another. On Wednesday, it would inspect a satellite. On Thursday, it would do maintenance. And on Friday, it would return to Earth, and it would gather up a piece of space junk and send it into the atmosphere.
However, according to the Airbus engineers who are currently developing space tugs, some technological problems remain.
What we cannot do at the moment is a scheduled rendezvous with a target that has not been designed for this purpose. For example, an old satellite or a piece of orbital debris.
A space rendezvous is an organized and controlled meeting between two space devices.
We need to develop new autonomous technologies that can manage on their own. They would be based on vision sensors that would scan the environment and analyze the contents of the images they acquire. And this data analysis will detect the parts of the objects that interest us in order to be able to catch them and manipulate them.
The Space Tug project is still being studied, but thanks to major funding, the first efficient cleaning service may come into use by 2025. As well as the European Space Agency and Envisat, Space Tugs already have other new clients. Private companies are currently sending thousands of satellites into low Earth orbit to create a new kind of network. These projects, known as mega-constellations, have already become a reality with satellites like SpaceX's Starlink or the OneWeb project. OneWeb's visionary entrepreneur managed to convince America's internet giants, as well as European Airbus, to make massive investments in the fabrication of a series of hundreds of satellites. Its aim? To guarantee internet access to the most remote parts of the globe.
OneWeb has designed, is building, and will soon be launching a constellation of satellites to bridge the digital divide, provide high-speed broadband access to the half of the world, the 4 billion people without access today. In the initial constellation, we're going to have 882 satellites.
In 2022, the number of mega-constellation satellites in orbit exceeds the number of satellites launched since the beginning of the space race. This has raised concerns among space debris specialists.
Mega-constellations are the big thing at the moment. For example, Starlink by SpaceX Elon Musk. Today, he has about 2,000 satellites in orbit in a first generation that will make 12,000, then a second generation that will make 42,000. There is also OneWeb. There are about 500 satellites, and there are many other constellations like this. We expect to have about 100,000 new satellites in orbit by 2030.
Yet the promoters of these mammoth projects maintain that they have taken all the precautions necessary.
There are some things we really need to think very carefully about, and creating some regulatory environment so that the deorbit and the operations are done in a manner consistent with long-term use of space for humanity.
We definitely have to think about how to clean up space debris, but we must also consider the option of imposing a space traffic system in the same way that we have a system for aviation.
There's also the danger that space will be filled with even more garbage. If there are failures, there are satellites that break down, which will then circle around as junk, and that's my concern, that there will be more space debris. It is well known that wherever people go, they leave rubbish in their wake.
We know where the ISS is. We know where our satellites are. We've done a lot of internal resiliency and redundancy to make sure we have control and management of our satellite for the deorbit phase.
Despite reassurances from their operators, mega-constellation satellites do sometimes stop working.
Today, with all these new satellites that we're sending into space, thousands, tens of thousands, hundreds of thousands of satellites, there's no problem, as long as they work.
But there are currently no international regulations in place.
The solution would have to come from above, from the United Nations, legislating and forcing people to get involved in cleaning up the space debris.
Yet most of the people engaged in space exploration claim to be advocating for policies.
We're concerned there is no global body that regulates this. It's a bunch of different groups thinking about regulating it, a bunch of different countries that have a variety of thoughts about regulation without actually putting meat on the bone.
The future of the space industry is promising. But on the contrary, the future of space orbits is more worrying. There are more players putting satellites into orbit. Not just large nations, but also smaller nations that have this capacity, their governments and their private companies.
While waiting for space to apply the polluter pays rule, orbital debris is a major concern for satellite operators. And although few people on Earth are aware of the problem, one day soon, our lives could be spinning out of control.